Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it. Hook. This one short question lost more marks than almost anything else on last year's papers. 2 counters drawn from a bag. Find the probability both are red. Simple words, but students split between 3 different answers. Sound familiar? Here's why that confusion is easy to fix, and why you absolutely need to hear this trick now.
The concept. Step 1. Build a clear picture. Imagine a bag with 3 red and 2 blue counters, 5 in total. We draw 2 counters, one after the other, without replacement. Draw a simple tree. 2 branches from the start. First red with probability 3/5 and first blue with probability 2/5. Write those fractions on the branches so nothing gets guessed later.
Now extend each branch. If the first was red, we have 1 fewer red left. 2 red and 2 blue remain, so the probability of a red second is 2/4, which simplifies to 1/2. So along the red-red branch, write 3/5, then 2/4. If the first was blue, the second red probability is 3/4. That's the difference replacement makes. Here the second probability depends on what happened first. Important rule. P of A and B equals P of A multiplied by P of B given A. On the tree, multiply along the branch. For 2 reds, P of R then R equals 3/5 multiplied by 2/4 equals 3/10. Say that out loud, or write it exactly like that on the paper. P of R and R equals 3/5 multiplied by 2/4 equals 3/10. Examiners love to see the phrase P of and the word and. Contrast with replacement. If after drawing you put the counter back and reshuffle, the second draw has the same probabilities as the first. For our bag with replacement, PR then R equals 3/5 times 3/5 equals 9/25. That difference, 3/10 versus 9/25, is where many students trip up because they forget to change the denominator for non-replacement.
Addition on trees. When 2 or more branches give the same final outcome, you add their probabilities. For example, the probability of exactly 1 red in 2 draws equals PR then B plus PB then R. Compute each branch and add. Don't be tempted to do anything fancy. Multiply then add is the safe mark-winning method.
Why multiplication works here. Each branch's product measures the joint chance of that exact sequence. Why addition is valid. Those sequences are mutually exclusive. They can't both happen at once, so their probabilities sum. Give that short explanation in words if you're unsure on a paper. It often earns method recognition and shows understanding. The exam technique. Translate each step to mark scheme language. For a typical 3-mark question, you'd see M1 for a correct tree or an expression of conditional probabilities, M1 for using multiplication on a branch correctly, and A1 for the fully correct final answer. So even if you can't finish, that tree and 1 correct branch can still earn a method mark. Remember, write it down, don't just think it.
Show intermediate lines. Good intermediate lines look like P, R and R equals 3/5 times 2/4 equals 3/10, and P, R and B equals 3/5 times 2/4 equals 3/10. Note I've written both full products before adding. Examiners award M marks for those exact method steps. If you instead write an answer without the setup, you're risking that if an arithmetic slip occurs, you lose marks.
Common traps. Treating non-replacement as independent.
double counting when adding, and answering probability of red when the question asked probability both are red. Read the question twice, solve it once. Let that sink in.
The quick win. One habit that catches most errors. Annotate every branch with the actual fraction and explicitly write P of A and B equals. When you write P of R and R equals 3/5 times 2/4 before calculating, you force yourself to use the correct denominators and conditional probabilities. Quick extra check. Use complements for at least questions. For example, at least one red equals 1 minus P of no reds. That 10-second check catches a lot of mistakes.
A tiny addition. Label whether the question is with replacement or without replacement on your paper before you start. If you write without replacement next to your tree, you won't accidentally use the original denominators twice. This is a grade 9 move that costs nothing and saves marks.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious. Practice prompt. 2 short questions to try now. Question 1. A bag contains 4 green and 1 yellow counter. 2 drawers without replacement. Find the probability both are green. Question 2. A bag contains 2 white and 3 black counters. 1 counter is drawn, replaced, and a second is drawn. Find the probability exactly one of the drawers is white. Pause the episode and try them on paper using the tree method we discussed. Quick guidance for parents and teachers. Check that students have labelled replacement or non-replacement, that each branch shows conditional fractions, and that they've written at least one branch product as P of A and B equals. If they did that, reward the method marks even when arithmetic is off. Then ask them to run the one-line complement or substitute check as follow-up. Final encouragement. Practice a handful of 2-stage trees each week and use the right P and label replacement habit. Marks are there for the taking. Stay curious and see you on the next episode of the GCSE Maths Advantage.